Hello Titan Dev team. Today we are going to be talking about injecting data into our RVT. Now, for those of you who don't know what RVT is, it is a runtime virtual texture, which is basically a massive streamed texture that we use across the entire world. Our landscape injects all of its data inside the RVT, so it injects its world position, its diffuse, its normal, its specular, its roughness, all of that stuff. And what that means is that we can then sample that big texture and then use it to blend between our assets. So you can see here we have our tree and it blends nicely into this landscape here. But it doesn't matter where I put this, I can put this anywhere in the world, and as long as it's sat on the landscape, it will always blend into that asset. Now, our problem occurs when we add some assets on top, which we'll do quite a lot. And you can see that we don't get any blend here. And that's because we're only sampling our landscape, and our landscape is down here, and we only have a small blend distance. So how do we go about fixing that? Well, the easy way to do it is to add this content to our RVT. Now, we need to be really careful about adding data into our RVT because we can run into issues. The biggest one is with overhang. RVT is a projection, which means that it just takes the asset and splats it down. That means that if you've taken this asset and you've put it over here and you've got a big landscape underneath it, it's going to sample that whole thing. So it now thinks that the landscape height will go from here to here to here and then go straight up to there, right? So we don't want that. So you need to be very careful about how you're using it and making sure that it's only in instances like this, where you've got bits of the landscape that you're replacing and you just want to change out that asset and you don't have any overhang to worry about. Now, the way that you go about doing this is a little bit convoluted, but bear with me. So we take our asset, we duplicate it, and then we type in nanite and tick disallow nanite. We have to do this because nanite meshes can't be injected into the RVT. Once we've done that, we can put it back where we found it, so it lines up. And then we go down to our virtual texture options on this asset, which is, brain stopped working, just going to type it in, which is right here. And we basically just need to mark out where it's going to inject into. So we can choose to inject this into our height map, RVT _ Titan _ H, or we can inject it into everything, which is RVT _ Titan _ D, and that will be our albedo, our normal, our specular, our roughness, and all that stuff. For this, we only need it for the blend, and we don't have a different material on top of this, so we can just leave it as is. So I'm going to just inject this into RVT _ H. But if we wanted to, we could just add another one by adding. The next thing we do is we go to draw in main pass and we set it to never. That's because this asset is already being rendered by the nanite asset, so we can already see it there. We don't need to see it twice and we don't want it duplicating on top. So we mark it as never, which will basically mean that it never gets visibly rendered. And if there's no runtime virtual texture support, then the asset is just stripped out completely. Now you can see that we've done that, we haven't actually got anything, and that's because we need to make one final change to this asset, and that's inside the material. So if we open that up, we can see that we've got a blended material here, so we need to open up our parent, and then inside here we need to tell it to inject the data in. Now a good example of this is inside our landscape material, and you can see that we actually don't even render our final output. So you can see all of our landscape layer blends here going into our landscape layer blend, and then the output gets put straight into a runtime virtual texture output. So basically saying all of the landscape information just injects straight into the RVT, and then what we display on the landscape is the actual end RVT value. So we just need to do that for this. So we just need our world position and our runtime virtual texture output. And we're going to go and open that and just paste that in. And that's going to tell it to take the absolute world position, so our asset's position in the world, and to inject that into our runtime virtual textures world height. Save it. And then go back to our asset and now you can see that our tree now has the nice blend layer on top of it. So you can use this technique to add the data in very easily. Like I said, tiny bit convoluted, but you can do it kind of mostly with that. So once we've done that, we can go and we can save that asset. That disallowed nanite mesh duplicate will never be seen, so we don't ever have to worry about it. We still use our nice nanite level mesh for our visual representation. We just use this one for the height. Now, one thing you will notice is that we've lost a little bit of quality on our actual nanite mesh here. This is one of the other downsides of doing this. So where this was originally using an RVT blend, so this rock asset was blending into the landscape, it was using that height map difference to blend between those two materials, blend between the RVT and between its original material. And you can see that that is no longer working. This is one of the downsides of that, because now we've injected that asset into the RVT. That's now the actual height position. So we now need to use a different solution to blend this asset into the landscape. Hope that was useful. And if you have any more questions, feel free to ask them in the Discord.